Alright, 5th grade. So you're going to have a while to do this assignment just because for spring break we're going to miss 2 of our classes. Like I mentioned today though, if you would like a time to meet to kind of get some more help, let me know. I am able to meet, even if you want to keep it that next Thursday. I'm not going to do a formal meeting because not everyone needs to be on there. It is spring break, but if you would like that extra help, I am willing to give it to you. Just reach out. So this is what I am going to have you guys work on. This is going to be uploaded as well after you watch this video. I would probably take a look at it beforehand because I'm going to use it right now. And then later you're going to actually complete the problems at the bottom. There's 8 problems. The top you're just telling me any equivalent fraction. This is kind of like what we were doing during class today, where you're taking them and multiplying by anything as long as the top and the bottom are the same. So your multiplier is the same on the numerator and the denominator. Down here, though, is when we're actually going to try and find equivalent fractions. So you're going to find how do I get from 1 to 4? Whatever I multiply, that multiplier has to be multiplied by the bottom. You're going to fill this in. This is what you're going to show me when we meet next time that we actually meet. You'll pull up the screen. If you don't have a camera on whatever screen you're using at the time, just take a picture of it, send it to my email, and we'll be all good. So you don't have to copy this. You can easily just write it out 1A, 1B, 1C, 1D, kind of like you would write out things for test corrections. If we were having a test like we have this year when I require test corrections and all of that. I'm going to go over the top. This is your notes. You can keep it. If you don't have a printer and you want to rewrite it, you may. Otherwise, I can print it off for you once we are able to go back to school and all of that. So, what we're doing today is finding equivalent fractions. This is probably one of the harder units. Once you understand this, though, everything else is so easy. So adding and subtracting fractions is just using equivalents. Multiplying and dividing fractions is actually very easy to do. We're saving that for the end because it won't take as long. We're probably going to do equivalent fractions for 2 more weeks of actually meeting, just because there are different ways to do it. If this is confusing for you, that's okay. It probably is going to be just because it's so new to most of us. This is kind of the basics of fractions. We're going to go away from the fraction strips this lesson, and then the next lesson we're going to start using them again. So don't get rid of those. If you want to use them, you're more than welcome to, but I'm going to show you an easier way to actually do it where you don't always need fraction strips, because when you have fractions that are like 2 30-seconds, you're not going to make 32 little pieces and grab 2 of them. That's just not realistic to always use. It's easy to and helpful to see when we start fractions, and we're going to kind of interchange it because I feel like this would be easier since we are learning from a computer, kind of. So whenever you have a fraction, you probably learned this last year, your top is your numerator, your bottom is your denominator. We went over that today. That's always how it's going to be. So when anything is calling for what is your numerator, you look at the number on the top. Whatever your denominator is, that's the number on the bottom. A fraction is just a division bar. Okay? So this is really saying whatever's on the top. So if I look down here, this is saying 2 divided by 3. That's all it is it's division, but it's called a fraction because there's easier ways to do it than always divide, because when you would divide these numbers, some of them you get some crazy decimals. So that's how I keep them as fractions. I hope that as we go through this, you start to enjoy using fractions and keep things as fractions. I personally think it's a lot easier. You might feel differently, but for these, we're going to go away from decimals, so we're not going to see decimals much. Okay, whenever you multiplying by something to find an equivalent fraction, these 2 numbers on the top have to be the same. It says the numbers are the same, and this is called your multiplier. So whenever I say, what is your multiplier that you're using, it's whatever number you're multiplying each part of the fraction by to get your new number. Once you multiply, you go straight across the top, straight across the bottom, or you're just going to multiply by the same number and get your new equivalent fraction. So an example of this is, if I have 2/3, I'm saying my multiplier is 4. That means the 4 goes on the top and the 4 goes on the bottom. When I was your age in 5th grade, I learned it as, if you put this around it, this makes a 1. Okay? And anything times 1 is itself, so it's not changing the value of a fraction at all. So as long as those 2 numbers are the same, it equals 1. It equals a whole. We kind of went over that today when I said give me examples of a whole. It was any number over the same number would equal that. When you're actually solving it, you don't have to write all these steps. I just wrote them out so you can see it. You're taking your first numerator times your multiplier, so 2 times 4, and you're getting 8. On the bottom, you're taking your denominator times your same multiplier, 4, 3 times 4, and you get 12. This says that 2/3 is equivalent to 8/12, and that is correct. If I was taking here, this is the harder part, when you're told a fraction and you're saying what is the equivalent in 18ths, you're looking at 2/3 is how many 18ths? You're saying from 3 to 18, it's getting bigger, so I multiply. If it would get smaller, I would divide. You're finding, what am I multiplying by? So in your head, you're either doing 3 times what is 18, or you can think in reverse and do 18 divided by 3 is, and you would get 6. I use multiplication. I like multiplication better. Some of you guys might like division better. I think most of you guys, after working with you for almost a full year so far, enjoy multiplication way more than division. So what I usually think in my head is 3 times what? If you're unsure, I list up the multiples. 3, 6, 9, 12, 15, 18, and see how many I get. Even if you want to write those on the side, like we have been doing, that is fine too. When you multiply by 6, that is your multiplier. That means you also multiply by 6 on the top, and 2 times 6 would be 12. Okay, so we're going to do some practice problems now. If that's a little confusing for you, I would say restart the video. Go through it again now that you have some background. You've heard it once. Listen to it again and see if you actually get it. Okay? We're going to do some practice though, so if you need to, pause it, go back. If you're ready to move on, make sure you have a blank sheet of paper somewhere. This page will be online for you guys to do the bottom part. Otherwise, you can just get a scrap sheet of paper, look at it online, still the problems are there, and write them down. Okay? So we're going to do some practice. I'm going to give you guys a fraction. Let's start with 4 fifths. Okay. I want to list equivalent fractions to 4 fifths. They can be whatever you want. That means all you have to do is pick any multiplier and multiply the numerator and denominator by that number. So take a second, actually pause this video, and write out about 3 or 4 different equivalent fractions. There is a bunch. If you're stuck on how to do that, an easy way is, okay, start with 2 as your multiplier. So multiply the top and the bottom both by 2. Then if I want another equivalent, I would rewrite it. And my new multiplier, okay, I did 2 last time, let's do 3 and go up. So give me about 3 to 4 problems. Pause this video. Don't let it keep running or I'm going to keep talking. And actually find them. Okay, so hopefully you have found some equivalent fractions. If my first one, I'm saying my multiplier is 2. That means all I'm going to do is multiply the top by 2 and the bottom by 2. And it's going to equal an equivalent fraction. My multiplier is 2, they're both 2. I will go straight across. 4 times 2, and I would get 8. And then I would say 5 times 2, and I would get 10. That means that 4 fifths is equivalent to 8 tenths. Okay? If my multiplier is 3, that means I would multiply my numerator by 3 and my denominator by 3, because when it's really 3 over 3, that is 1. It's not changing the value of this problem at all. All it's doing is taking the number of pieces and breaking them up to even more. A good way to think about this, if you think about like pizza, if you have half a pizza left and you divide that up into more pieces, it's still the same amount, it's just in different pieces. So when you do it, your multiplier is 3. 4 times 3 would get 12. And 5 times 3, you would get 15. That means that 4 fifths is equivalent to 12 fifteenths. Some other fractions you can get, if my multiplier is 4, that means I would multiply my top by 4, my bottom by 4. You need to have your multiplication facts really good to be able to do all these, because if you don't have your multiplication facts really good, then this would be pretty hard. A good thing, you could use your multiplication table if that's something you've been working with all year. You would already know that. If you haven't been, that's not a time to start. You already have your multiplication facts down. You guys are good. We'll do one more. Let's say our multiplier is 5. If my multiplier is 5, that means my top gets multiplied by 5 and my bottom multiplied by 5. 4 times 5, you would get 20, and 5 times 5, you would get 25. This means that 4 fifths equals 8 tenths, it equals 12 fifteenths, it equals 16 twentieths, and it equals 20 25ths. They are all equivalent fractions, just broken up into more pieces with more parts. If I would make fraction strips, they would all be exactly the same as another. Okay, let's try another fraction. Let's try 6/7 is my fraction. I want you to give me, if my multiplier is 2, give me an equivalent if my multiplier is 5, and I want you to find an equivalent if my multiplier is 10. So what are my equivalents? Go ahead and pause this video and actually solve for it. Make sure you're pausing and actually solving for it. Otherwise, you're not going to learn from it. So hopefully you have paused it and you have found some equivalent fractions. You will now have 4 different equivalent fractions because 6/7 is going to be equivalent to this, it's going to be equivalent to this, and it's going to be equivalent to that last one. Okay. When your multiplier is 2, that means you multiply your top by 2, your bottom by 2. Okay, you now need to know your multiplication facts with 6. 6 times 2 is 12. 7 times 2 is 14. That means that 6/7 and 12/14 are equivalent. If my multiplier is 5, that means I multiply my top by 5, my bottom by 5. Numerator, 6 times 5, you get 30. Denominator, 7 times 5, I would get 35. That means that 35ths is equal to 6/7. And my last one, if my multiplier is 10, that means I multiply my numerator by 10, my denominator by 10. 6 times 10 is 60, 7 times 10 is 70. Okay? So these are the easier ones when you can write any equivalent fraction. You can even go from here, 67, 70th, and multiply that by 10 again. That's still equivalent. You're just getting into huge numbers that equal the same amount. Okay? If I would divide these all out, 6 divided by 7, 60 divided by 70, I would get the exact same decimal. It'd be a really long decimal, but you would have the same decimal. So let's start our next section. This is where you have a fraction, and it wants you to tell the exact equivalent. This is what we're going to start using a lot when we add and subtract. So we're going to start with a basic fraction of 3/4. Okay, you have 3/4, and maybe the problem is asking you 3/4 is equivalent to how many 20ths? Okay, typically when this happens, this is going to be a very common multiplication problem. Very rarely it won't be. If it's something where you can't figure it out, it's probably the problem might have been written wrong on my end. Now the ones you have today are written wrong, so there's always a clear answer. You will typically see like a box up here or a question mark or something that's saying this is missing. We need to find this. Okay? We cannot pick any multiplier we want because if I pick any multiplier I want, maybe I want 2, multiply top by 2 and bottom by 2, 4 times 2 is not 20. It's 8. Okay? So this is where you're trying to find what is the multiplier. So you're trying to find what am I multiplying the numerator and denominator by. They have to be the same number. Your multiplier is always the same on the numerator and the denominator. So if you're doing it, you're saying how do I get from 4 to 20? You can do this 2 ways. If you like division, you could do 20 divided by 4. Most of you don't like division. We just finished a whole division unit and you did not really enjoy it. So my suggestion would be to think about multiplying it. Think about your facts. So 4 times what is 20? Most of you should know that that would be 5 because 4 times 5 is 20. If you don't see that right away, an easy thing to do is you are all very good at listing your multiples. Start with 4. Add up. Give me the multiples of 4. 4, 8, 12, 16, 20. I found 20. That's what I'm looking for. And how many numbers down is it? It's 1, 2, 3, 4, 5. That's telling you your multiplier is 5. So when you have bigger numbers, this is a great method to use that we have used all year long of listing our multiples to find it. You don't have to use this. Most of these problems are in your head, basic facts. You're just trying to find that missing value. It's not as clear-cut of this is what the steps you do. It's more thinking in your head, how do I get there? If you need the steps, this is the steps that you would follow. This says my multiplier has to be 5 because from 4 times 5 I would get 20, and that's what I want. That means on the numerator I need to do the same multiplier. So I need to multiply by 5. So 3 times 5 would be 15. That means that 3/4 is equivalent to 15 20ths. Okay, I'm going to give you guys a couple to do on your own. You're going to pause. We're going to go one by one now, so I'm not giving you a bunch and having you pause. I'm going to pause it, give you one, have you pause, and then we'll go over it. Let's try 2/5. I want to know 2/5 is equivalent to how many 30ths? Okay, so I'm trying to find what is my missing numerator. Go ahead and pause this video and find out how many 30ths is 2/5. Hopefully you have found that by now. If you needed to, you would have listed your multiples of 5 because that's what you're starting at. You're trying to find how do I get from 5 to 30. I'm going to show the multiples in case you did it. You don't have to do it. Most of you probably know in your head the exact answer that occurred. So if I'm listing my multiples, 5, 10, 15, 20, 25, 30, I got 30. If you're confused on this part, this is just counting up. Skip counting by 5s. Or you can add 5 each time. Add another 5. Add another 5. Now, I got 30, so I know it works. I need to count down. 1, 2, 3, 4, 5. This is my 6th number. That means your multiplier is 6. 5 times 6 is 30, so that is correct. That means on the numerator, I also should have multiplied by 6, and your answer you should have gotten was 12 30ths, meaning that 2/5 is equivalent to 12 30ths. Okay, let's do another one. Let's say that I am working with 8s. 3/8 is how many 64ths? So now I'm getting pretty big. This is a basic multiplication fact, common multiple here. If you're unsure, you would be listing your multiple of whatever you're starting at. How do I get from 8 to 64? Go ahead and solve this. Pause the video. Alright, so you should have found how do I get from 8 to 64? 8 times what is 64? Most of you probably already saw what that is. In case you did not, do it just in your head, which is completely fine. You would list your multiples of 8. So 8, skip count by 8s, 16, 24, 32, 40, still not there, so keep going, 48, 56, and I would get 64. Then I would count down. 1, 2, 3, 4, 5, 6, 7. This is my 8th number. That means my multiplier is 8. Okay, and when you do that, your multiplier needs to be the same on the top. Now, if these bigger numbers are a little hard for you, you know that it's 3 times 8. Here's our multiples of 8. So count down 3 numbers, and that would be your answer. Or you can go straight across the top. 3 times 8, and you should have gotten 24. Let's do one more where we're missing the numerator. Let's say that I have 1/7 equals how many 28ths? Okay, so go ahead, pause the video. You are looking for your numerator here. Hopefully you found it. If not, you're looking how do I get from 7 to 28. That means you would either list your multiples of 7, or you would say 7 times what is 28? You should get 4. If you don't have that though, you would list your multiples 14, 21, 28. You see it? It's the 4th number. That means 4 is your multiplier. Then you would do 1 times 4, and you should get 4 28ths is equal to 1/7. Okay, we're going to do a couple with a different way. It's the same exact method if you're solving for the denominator. Maybe you know the numerator. So maybe you have 3 this equals 12 over what? Now you're missing your denominator. You do the same exact method, except now you're going to use your multiplier on the bottom for the second time instead of the top. Go ahead and pause the video and try and solve this. Hopefully you found it. If not, you're finding how do I get from 3 to 12, which we should all know. In case we don't, you would list your multiples: 3, 6, 9, 12. That is your fourth number down. There we go. That means your multiplier is 4. And it means you do the same on the bottom. Okay? And 5 times 4 would be 20. So 3/5 is equivalent to 12/20ths. You could do the exact same thing. Maybe I know that this is... Maybe it's backwards here. Okay, maybe I'm looking for the first number I don't know. You would do the same thing, but now you're finding how do I get from 1 to 9? Okay, take a second, pause this. You might already have the answer. Getting from 1 to 9, you would multiply by 9. If I list my multiples, 1, 2, 3, 4, 5, 6, 7, 8, 9. I got there eventually. Even if you're using 1, you could still do it. That means it's my 9th number. That means my multiplier is 9. And 2 times 9, you should have 18. So, any format you do, this method will always work no matter what number is missing, whether it's part of your first fraction, whether it's a numerator, whether it's denominator. As long as you have one part of one fraction and another whole fraction, this will work. So hopefully this helped. If you need some extra videos to watch, or you need me to make something else for you, or we need to meet, if you're seeing this before tomorrow, you can come onto Zoom on 10 o'clock on Friday. Otherwise, I will see you guys the next time we meet for Zoom. Have a great weekend, and I won't see you guys next week, so have a great spring break as well. If you need anything, let me know.